Oh, you are?
Yeah,
okay.
that one, it wasn't working for me, so I just used the arrow keys.
Okay.
The pointer works, but the arrows weren't working.
Cool. Okay, thank you all for coming. So my background is actually as an academic. I just started at Data Camp in June. So I want to start off and just ask you a few questions to try to get a sense for who you are, what your background is, what you know about in the data science world. So who has used R before? Oh, that's beautiful. I need a photo of all of this. This is fantastic. Who has heard of Data Camp? Okay, so this is good. So I started Data Camp. Miguel was very nice and said that I am the curriculum lead at Data Camp. There's actually 7 of us that are curriculum leads, so this is a very interesting title. It's like division head, except there's 7 division heads. But it's a great title. I think it's fantastic. Curriculum lead at Data Camp. So what I do at Data Camp is I work with instructors on building courses for Data Camp. So our courses are not like a full university long, semester long thing. This is much more like a boot camp, a 4 to 5 hour boot camp. Interactive coding, helping students learn R, Python, SQL, and soon Git and Bash as well. So it's all about data science. So how in the world does this background and what my job is lead to this title, which comes from a marriage rhyme, right? Well, we'll get there. What I'm expecting you, the background knowledge for you to have in this course, in this video and my presentation is absolutely nothing. Okay, so I'm going to assume you know no things. There will be many GIFs. There will be many images. It is okay if you laugh. It is okay if you have a good time during all of this. Okay, so this is not a very formal presentation. So the subtitle here is Ways to Teach Data Science and Learn It Too. I'm not saying that I know exactly how to teach data science, but I'm going to present you with some ideas that have worked well for me in the classroom. So you will see a link here at the bottom that is a link to the slides. So if you have a computer or after the fact, if you want to go and check out these slides, feel free to do so. A lot of this is going to be talking about this textbook. This is moderndive.com. It might sound a little weird. What's a stats textbook that has Modern Dive as the title? There's a big backstory behind that, but it's really about a modern dive into data with R. So that's why I asked you. R is the background behind so much of what I've done in statistics and what I've tried to teach intro stat students to use more and more and more. And so these are ways that I've had intro stat students with absolutely no background, have really no interest in statistics, be able to do really cool things. And I'll show you some examples of the cool things that they've been able to do using this textbook and other technologies that I've implemented. Okay, so all of this is a really, I think, a bold strategy of thinking about what happens in the classroom and even thinking about what textbooks might become in the future. So Wikipedia has destroyed the encyclopedia industry. Is it fair to say that? Do you all have Britannica that you go home and check at night, or do you just go to Wikipedia to look things up? You all have Wikipedia, right? We just all go look on our phones. We all have Wikipedia when we want to look up information. This is a really interesting story, but Microsoft Encarta started at exactly the same time as Wikipedia. They had all of the experts, they had all of this stuff ready to roll, and they released, and no one has Microsoft Encarta anymore. So I am thinking in the future, potentially textbooks are all available online for free, and anyone can make suggestions and edits to those textbooks. I don't know if that's going to actually happen, but I suspect that that will be the way that we go. Okay, so we'll see if it actually pays off. Okay, for me, because that's exactly what I did with the collaborator. Okay, so something old, something new, something borrowed, and something blue. So I'm going to have you guess, not right now, but I will have you guess as we progress along what blue stands for. But I'll give you some hints for what I mean by old, new, and borrowed. So when you teach statistics or when you teach data science, you might think, okay, maybe they'll do some slides, the professor, maybe they'll do a little bit of live programming. What we found, Albert Kim and I, my co-author, is that actually going to the chalkboard and doing that and writing code on the chalkboard, slowing down, having students think about what you're doing is a really powerful way to teach, especially data science. The new aspect, so I work at Data Camp. I heard about Data Camp when I was still a professor. So I taught a class at Pacific University in Forest Grove, then I worked at Reed College before I got my job at Data Camp. And so I found out that I could actually embed Data Camp into my class. So students would do for homework the stuff that we talked about in class. And I didn't have to do the grading. I had already set up the Data Camp chapter to do all the testing and give them immediate feedback. And that was really powerful and great as well. Borrowed. So Borrowed is about open source technology. I was not the first person to do this. R is an open source product. I'm going to use a package called Bookdown. I use a package called Bookdown to develop the book. I borrowed that from that. And so more and more, I encourage you to borrow stuff that has already been done. Don't write your own R code from scratch. Somebody else potentially already did it, and you just need to tweak the stuff just a little tiny bit. And then we'll get back to glue at the end. Okay, something old. So like I said, I was a professor and I did this. I had students, I looked at them like, don't you understand my slides? Isn't this engaging and interesting? It's funny that I say this as I have slides. Okay, so I realize this is a little weird, this is a little strange. But I think we try to convey information. We want to convey a ton of information to people that are in our audience. But that's really hard for students and it's really hard for us to try to get that information out there. So Albert Kim, this is a picture that he took of his slides, a lecture that he gave earlier this year. Does anybody know where this definition comes from? Charlotte, you can't answer. There's a huge hint. Yeah, ggplot. Okay, so what does the red code correspond to? Just in general, is like that regular text, or is it something maybe specific to R? So this is ggplot R code, right? So using colors is a really powerful way for students to understand what's going on when they're seeing code, when they're seeing text. Okay? So this was the very introductory lecture on talking about what a statistical graphic is about, and getting students to understand this is the background behind ggplot. Okay, and then our textbook has decided to focus on just 5 introductory plots, graphs. These are by far not the only plots that you could ever use, but it's a nice way to get students going and understanding what data viz is all about. Okay? This is another fascinating thing. So when I go to campuses now and I look around, I will sit in a lecture. It's amazing the number of students that just pop a laptop up and they take, maybe they're not on Facebook, maybe they're not on Twitter, they're actually taking notes. I was this person. I actually took notes, and then I would think back, every now and then I would take notes on the computer, other classes I would try to take notes by hand. And there is scientific evidence that supports the fact that we should be taking notes by hand. Okay? That doesn't mean when you are programming, obviously you have to enter code into the computer, right? You can't do everything by hand. But it's way more powerful for your learning if you are digesting what is said and taking those notes by hand. Okay? So the only way that we could really do this as professors was to slow down. It was impossible to have slides with a lot of information and also expect students to write all of the notes by hand. Okay? So at the absolute very least, as I was presenting materials, lecture slows me down when I actually have to go to that chalkboard and very carefully write things down. Because if I write too fast, it's going to be really sloppy. The students are going to say, oh, what does that say? I don't know what that says, right? So, and this doesn't just go for professors. I'm not just talking to professors. I'm sure you all have friends that might have to take a stats class. And you might need to teach them some ideas. I'm going to say, don't just immediately have them load up R and immediately hop in there and do stuff. Like, try to talk about that stuff via pencil and paper, go to the board, talk about the ideas in that way. Okay, so that was old. New, I kind of already talked about this a little bit. Data camp. And it's so awesome to see so many of you have had some exposure in R or a different programming language. You're not just doing point and click stuff. Coding and learning about digital literacy will be the reading of the future. And you might have friends that say, I'm never going to have to program. I don't need to program. I don't need to do that. And another bold idea, they're going to have to do it. Okay? And at the very least, the last job that computers will take from us is computer programming. The last thing a computer will ever be able to do is program itself. Right? So if we could just stay ahead of that just a little tiny bit while also still doing cool stuff in data science, we should. Okay? Oh yeah, another thing, all of my stuff, these are all links to the actual article as well. So you can hover over these and you can click on them and you can go read the stuff as much as possible. If I stole a GIF from somewhere, you can click on the GIF and it will go to Giphy and you actually have the link as much as possible. Okay? So I'm all about reproducibility. I'm all about just giving people exactly what I'm thinking, even if it's not completely done. So that's supporting that. Any basketball fans? Okay. So I knew this was going to be like, not really. It was going to kind of alienate you a little bit. So this is a very, who has seen this at least in the past as a meme? Okay, basketball fans have, okay, other people have as well. So that's good. This is Allen Iverson. So I don't remember when this was, like early 2000s. He was missing practice, and his coach said, somebody asked him a question, and he said, well, it's not the game, it's just practice, right? But that's actually pretty absurd, right? If you think about this, if you are learning to program for the very first time, it very much is about the practice. And this is just like learning a foreign language. If you have a friend that speaks Spanish and you want to eventually be able to speak Spanish with them, you know no Spanish, sorry, you can't just talk once a week and learn Spanish, right? You can try that as hard as you can, but you will forget those words, you won't remember them. You need practice and continual practice to learn how to program. That's why people are not, that's why every single person in the world is not programming, in my opinion. They don't have the time to practice. It's a lot of work, but you eventually get over that hump and you can do great things. Okay, so data camp. I'm just plugging Charlotte tonight, but this is a link from Charlotte's course. Charlotte, wait, come over here. Tyler Corr's course, many courses for us, function in R. Okay? And this interactivity is extremely powerful for students. When students start with R, if you tell them, let's go load up R, let's go download things, and they enter code, and they get this scary red, error message. My computer is blowing up. I messed everything up. In data camp, it's like, it's in the browser. I enter wrong websites all the time. It's okay. I can keep going, right? So data camp provides a really nice interactive way for students to learn how to do not just basic R, but modeling, graphics, data manipulation. Lots of these powerful skills are built into our model, learning by doing. Okay? So you can click on this. A shameless plug, I have to. All of the first chapters of every one of our courses are free to everyone. So you can just go play with it and test it out. We have multiple free courses. If you have a professor that uses R at all in their course, you should tell them that they can sign up through academic groups and get you and themselves access to all of our data camp courses from beginning to end for free for 6 months. Okay? So feel free to chat with me if you're interested in that. Data camp is really the way to go. I was not completely sold, then I had my students use it, and it was amazing at the end when I saw the final exam that was pencil and paper, that they remembered how to do ggplot code. They remembered how to do dplyr code via pencil and paper by using data camp as homework. Okay? So that's an anecdote. I realize that's n equals 1. We all frown on that, but it's incredibly powerful. I think it's definitely the way to go. Okay, so another thing that we do in class is, this is like almost a flipped classroom model, but not exactly. I don't even know what that really means. It's like the hip, cool thing. But students work on code in class, in groups, and then we come back and talk about things as needed as a class. So my lectures are like data camp style, little tiny 3 or 5 minute lectures. This was like before, obviously I'm not teaching classes anymore, I'm full-time at data camp, but I kind of followed that model with my in-person classes as well. This is a total stock photo. Okay, I didn't take any pictures of my students, so total stop, but this is the best I can find. So I'm not going to click on any one of these, but I wrote this package called, well, I co-authored this package called the 538. Our package, who knows about 538? Who works at 538? Who's the biggest person at 538? Nate Silver, okay, so election prediction sort of thing. So they posted a lot of their data sets and their code to GitHub. And I thought, okay, this is kind of cool, but why don't we just load that in as an R package? So we reached out to them and they said, okay, that sounds cool. So you can download the 538 R package and get access to a lot of the data sets that actually go into the stories. So what I did last semester was I had my students that had no programming experience at all coming into the class. 7 weeks into the class, they produced the vignettes. These are Markdown package vignettes that I highly recommend you just go check. Okay? It's amazing what they decided to do, really powerful stuff, and Albert Kim had his students do the same sort of thing for a final project. Okay? So I'm going to tease you. If we have time, we'll come back to this. So I just want to say that you, professors and students alike, you all have the power to do really amazing things in data science or statistics or whatever. Just keep working at it and let people know what you're working on. And be nice to people, okay? When they're like saying, I'm working on this cool project, like hear them out and have them show them your stuff and like collaborate and work together on things. It's really hard to solve problems by yourself. It's really, I think, easy to work with other people and like bounce ideas off, okay? So empower yourself, empower your students. Okay, something borrowed. So this is also a link. This is one of my favorite things. This is a book-down book about writing books with book-down. This is like data science inception or something, okay? So I read this book, and who has used R Markdown here? Okay, so this is like, just preach it to the choir. You guys all know about this stuff. Who knows about book-down? Okay, so just a few of you. So book-down is a way to take those R Markdown documents and kind of link them all together. So say you had chapter 1 as an R Markdown document, and you had chapter 2 as a different R Markdown document. But you wanted to somehow cross-reference the stuff that's in chapter 1 and chapter 2. Book-down allows you a way to have links that go from one chapter to the next, while also automatically numbering all of your figures, having references come in appropriately, do all that kind of stuff, and also output books to different formats. So you can have a PDF version of your book. You can have an HTML version of your book that you host on the web page. You can have an EPUB where you're like reading your stats textbook on your iPad or something like that. But the cool thing about that is you only have kind of one R Markdown source. So you can just say, build all of these different versions and distribute it out. Okay? So really powerful, great book. And so this really got us thinking. This is what I was talking about earlier. Textbooks having versions, just like software. So when you download an R package, it's like dplyr 0.6.0. Why don't we do the same thing with textbooks? Right? Do we really have to have an edition 1, an edition 2, like an edition 2 a year later that fixed 4 typos? Do we really need to have a whole new printing of a textbook? I don't think that's the case. I think that we can have versions. We can say, this is our textbook, moderndive.com, version 0.1. It's got a lot of work to go forward, but we're putting it out there. And people can see our source code. They can make edits kind of as needed. Okay? So, yeah, we just realized that we just have to let our stuff be out there. It's not going to be perfect. Our first version is never going to be excellent, but just get it out there and let people give us feedback. Okay, so this is a link. This is kind of going to the same thing, but our book, Modern Dive, is hosted as a GitHub repo. Who knows about GitHub? Okay, that's almost everyone. That is good. Okay, I was going to say, if there's only like a third of you, you have to get a GitHub account, and you have to keep going with this. Okay, GitHub allows you to collaborate, to have pull requests. So if you make a little change, you say there's a typo somewhere, you can make a pull request on Happy Wicked's book. You can make a pull request on my book. I'm not going to put myself on Happy Wicked, but on any of that stuff, you can make little changes, and you can actually be a collaborator on packages just by finding a typo somewhere. And this is an incredibly powerful tool in an open source program. So no more errata. What actually happens So Albert Kim, my collaborator, is still teaching. He teaches at Amherst College in Massachusetts. And when he finds a typo in class, he can actually go into GitHub, go into the R Markdown document, make a little change, and then we have continuous integration that's always looking at that code and building it, and then it automatically updates like 2 or 3 minutes later. And so he doesn't have to ever worry about like, oh yeah, there's a mistake, I have to fix that in the next version. You can just fix it right there. Okay? It's a really kind of powerful paradigm. Okay, something blue. So what is blue in statistics that you, okay, there is actually a blue thing I realized, right? Bias, what is that? Bias estimator. What's the B again?
Best.
Yeah, best. I'm too far removed, right? I am the industry guy now. It's okay that I don't know these things. Yeah, okay, it's not that. Okay. It's not whatever that stats term is. What's something that is blue that, actually, there's a logo, maybe that's blue, that you know about? Okay, so R Studio is one logo. What's another thing that's blue? Actually, our logo, right? Even the R logo is blue. Okay, so we also went for the blue logo, and I do have hex stickers. So obviously, you're not gonna like this is if you want a hex sticker, come up and see me afterwards. So remember, we branded ourselves as Modern Dive without really thinking about this, and then we had to try to figure out what's a cool logo that we could do that somehow ties these things together. And neither Albert or I are very creative people, so we crowdsourced our logo and we came up with this. Pretty cool, right? So the something blue is the interaction that R has with R Studio and with our textbook Modern Dive. Okay, both R and our Studio are really the backbone behind our textbook. Okay, the textbook is driven by data visualization. So we have an introductory chapter just to kind of give people a sense of what the book includes. If you're a student, what you kind of expect to be able to do by reading the book. And there's links to those same vignettes in those R Markdown reports that I had before. If you're a professor and you're potentially interested in using this in some way, this is the reasons why we made these choices, all that kind of stuff. Chapter 2 is all about getting started. So this is actually something that we added later on. But we thought about this when we said, oh yeah, this book is at a very basic beginner level. And then we realized, wait, we don't fully understand what a beginner is like. Okay, so we reached out to someone, to a cognitive psychologist, and she provided us with a ton of feedback on what it actually means to be a beginner in statistics. And so this chapter 2, has a bunch of different links to data camp courses, just to kind of get you up to speed on what some of this terminology and stuff is. Okay? And then we hop into chapter 3. We're not even going to do like the basic sort of intro stats, sort of boom, 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 boom. We're going to hop right in there and do ggplot as soon as we possibly can. Okay, that's chapter 3. And then we do data tidying. The students always have the data in a funky kind of format. I think I actually like tidyr the best of any of the packages. I love ggplot2. I love dplyr. But when you can take funky data and make it in the right format and then be able to use stuff later on, that's really awesome. Okay, I see some blank stares. Who has used tidyr? Well, maybe you're tired, you want to go home. Okay, the blank stares. Okay, so we're getting there. Okay, just a few more things. And then we hop into dplyr. Okay, so I've cut off kind of the bottom few chapters of our book. We have a chapter on regression and modeling that we're continuing to build. And then we have chapters on statistical inference. So this book was designed to be kind of a bridge between a traditional intro stats curriculum, like a stat methods course maybe that you take at the graduate level, and data science. So we're using data science tools all throughout the course as well. So I'm going to talk about why I kind of chopped this off in just a little bit. Okay, who has seen this diagram before? Oh, Jess has, but that's because I showed it to her before. So think about hypothesis testing. You have to really kind of think about this. But I'm going to make the bold claim that really all of hypothesis testing could be boiled down to this. Now, do you see like a assumptions about a distribution? Do you see like a t-curve, a normal curve, anything in here? Why do I not see a normal curve in this idea? Any thoughts? Yes?
Argue that your model of the null hypothesis is an assumption about the distribution, actually.
Yeah, okay. So fair enough. Okay, so maybe you are saying hidden in here is a normal distribution.
Or something.
Or something, right? Yeah, but the thing is, it doesn't have to just be a normal distribution, right? You could maybe assume something different and it still follows this model. Excellent point. Thank you. Okay. So do you kind of agree with me here that really you could simulate data assuming that the null hypothesis is true, get some sort of distribution out, and then kind of see where does what I have for the observed statistic fall out of the distribution. And that would give you at least an approximate feedback, right? So I love this diagram. I saw it about a year ago. This is from Alan Downey, who wrote the book Think Bayes, in Python, maybe something like that. So there's a bunch of stuff in Python. But there is no really great way in R to do this exact thing. And especially, I think, this step right here. And when I say R, I'm assuming students only know at this point dplyr, tidyr, and ggplot2. Okay, so we haven't done for loops. We haven't used the replicate function, anything like that. And there's no really easy way to do this. So Andrew Gray and I over the summer, and up until like yesterday, are continuing to work on this package. We're going to continue to work on this package. And it's a way to kind of use that same Alan Downey diagram, but have nicer verbs. Okay, so there's a specify function that you won't see here that specifies what the two or multiple variables are that you're working with. So you can specify a formula. Then you're going to state, what does your null hypothesis look like? And now we only have implemented null equals independence. You're checking to see if the two variables are independent of each other, or you're testing a point hypothesis. You're saying, I'm going to see if this point actually is fair. Okay? So you're going to hypothesize something. Then you're going to generate. Okay? So like dplyr has verbs like filter and mutate and select, things that actually make sense to you. Infer is doing the same sort of thing, hopefully, with statistical inference following that model. You generate, you calculate some stat. Okay, so here you can calculate a mean, a median. Hopefully down the road you can do whatever thing you want for a stat there. So we're hoping this is a general purpose kind of thing. And then the last step here is visualize, which is just going to use ggplot. Okay, kind of in a nice way. So if you want to play around with this, I'm going a little bit crazy here and telling you you should install from my development branch. Okay, so this has not been thoroughly tested. You might get crazy things happen. Proceed at your own risk. But if you click on this infer package up at the link up at the top here, we do have a package down site that's already kind of set up. Infer.netlify.com has the same link there. And then these are all of the different tests that we have currently implemented. So all of the like traditional intro stats sort of curriculum. We have an ANOVA. This is what it looks like. And I have 8 empty cars, but it's robust enough that I'll just put it forward with a bunch of different examples. Okay? So empty cars, you just want to specify miles per gallon versus the SIL variable, and then you can calculate that statistic in that way. Okay? Another cool thing is the package down is it actually generates your vignettes in a nice way. So, I don't know how much time I have. Minusculely, okay, that's good. So, I just want to show you an example here of what this might look like. Okay, so just setting up the data. Actually, we have a function called T underscore test. We're embracing the underscore, just like the tidyverse does. This is a nice wrapper for the t.test, the usual function. And then I have another wrapper function called T underscore stat. So if you just wanted the test statistic, for these two variables, you can just use t underscore stack. That's not really the cool thing. I think the cool thing here is the randomization-based approach. So we're going to use a test stack that is the t, and we're going to permute on these two variables. We're going to do that 1,000 times, assuming that arrival delay is independent of, I just split the year in half. So there's like beginning of the year and end of the year. This is an interesting thing. Maybe does weather affect or does it not? And we actually find out that this is a really massive p-value, right? Okay. So those are not statistically significant. But what if we actually wanted to go back and see what the t-curve looked like? Well, you can go directly from hypothesize into visualize and just get the t-curve out with the observed statistics shown here. And eventually I'll shade that too. Now, what if you wanted to see, what does the t distribution look like of the permuted statistics compared to what the actual t-curve looks like? So you can say, oh, okay, I could have used randomization here, or I could have just done the traditional t-curve. Okay? So this is all in development. The t distribution is developed, the two-sample t, the chi-square, and the f. And I'm going to continue to build those out as we go. Okay, again, I'll just wrap up, which is good. So future plans, we want to take the second half of our book and just make it completely about infer. And so we can build off of those things. We're going to rewrite the inference part. We're going to extend the modeling part, go a little bit further. Like I said, this is a work in progress, and Albert is working on that right now. We have a free data camp course that you can take that builds off of the book. That's what I wrote last semester when I was teaching. And then we want to continue to lead workshops and show students and show faculty that maybe this is another way to have students extend their dplyr knowledge into the statistical inference as well. Okay? Thank you all for attending and for staying awake.
Time for a couple questions.
Yes.
The last point, but I'm a little concerned by the equating of the permutation randomization test and the t-test. They don't test quite the same thing. And I feel like it's a trend lately that these resampling-based methods are being pushed in place of our central limit theorem-based methods.
Yes.
And they don't answer the same questions. So, and it's important to remember that the randomization hypothesis is that the two distributions are identical, not just that they have the same mean or same median or whatever parameter you're interested in. So they won't always perform validly.
Yeah. So again, we are making further assumptions by overlaying that t distribution on top of the permutation. We're saying we're also checking for the means being equivalent in addition to the distributions being, well, the distributions are equivalent, then obviously the means are equivalent, right?
Yes.
Yeah.
It's testing a stronger hypothesis. So we haven't gotten rid of assumptions, we just exchanged them.
Gotcha. Yeah, that's fair. Yeah. I will add that into what we're definitely saying. Yeah. Other questions?
Wait, if we don't have any, then we shall adjourn, and the next meeting will probably be sometime. Oh, there's one more.
Yes. Sorry, I can't quite hear you. Sure, yeah, so if you go, I usually just search DataCamp Academic, and it just brings you up this first page right here, DataCamp for Academics. If you click on that, you can submit a form, and then someone on my team will get back to you, potentially how you can do that and walk you through all the steps. Thank you.
Let's thank our two speakers again.